Welcome everyone. I came across an interesting math exercise from a Dutch final exam. This exercise is from the highest high school level in the Netherlands, and here is a list of the equivalent levels in other countries. You might want to pause it. Have a look if your country is there. If you feel that you're just below this level, I highly recommend following along with this video anyway. Understanding exercises at this level will make exercises one level below like a walk in the park. So now let's delve into today's exercise, which is a calculus problem. Are you ready? Let's dive in. Exam is a very stressful situation, but always take your time to read the question properly. So here we go. In the figure, the graphs of the functions f and g are plotted, given by f of x is the root of x and g of x is half the root of x. Furthermore, the lines are drawn with equations x equals a and x equals 4, where a is between 0 and 4. There's the figure. In the figure, two areas are shaded in gray. One area is bounded by the graphs of f and g and the line with equation x equals a. The other gray area is bounded by the graph of g, the x-axis, and the lines with equations x is a and x is 4. Exercise. Calculate exactly for which value of a these shaded areas have equal surface area. Now we need to come up with some kind of strategy to address this question. I think a good strategy would be to start with calculating the areas separately. So we need to determine the exact expressions for each surface area. Let's give them a name. This is area 1 and this is area 2. So how are we going to calculate the surface area of area 1? I would suggest that we first take the surface area under the graph of f, which is this, and expressed by the integral from 0 to a of the function f of x times dx. Then we need to subtract the surface area under g. In this case, we will be left with the surface area of area 1 only. We're going to tidy this equation up a bit, and we get this, and now we're going to fill out the actual formula, which is this. Working it out, you get to this. The integral from 0 to a, half the square root of x times dx. Now similarly for g, but for g I think it's a bit more easy because you only need to calculate the surface area under the graph of g itself. So here's the expressions. Be careful to use the correct interval. So this one goes from a to 4, g of x times dx equals the integral from a to 4 half square root of x times dx. Now area 1 and area 2 according to this question should be the same. So here's the corresponding equation. And from this point onwards something interesting has happened. We have now made a strategy and we came up with this equation. From this point onwards we do not have to think much anymore. From this point onwards we just need to work this out and get to the answer. So let's do so. We need to determine the antiderivative of half the square root of x. It might make it easier to remember that half the square root of x equals half times x to the power half, because then the rule for integrating, which is written here, can be applied. Now in our case, n equals half. So filling this out for half times x to the power half would lead to this expression. And just working this out, you get to this, and then you get to this, 1/3 x to the power 3/2. Remember, if you take an integral, never forget the constant. Points will be subtracted if you do. So filling out the integral's boundaries leads to the expression for surface area 1, and I wanted to write it down here, but we ran out of space. So let me tidy up a bit. There we are. Filling out the integral's boundaries leads to the expression for surface area 1. Again, the full integral, including the constant, on the interval from 0 to a, leads to this expression. Then we're going to do exactly the same for area 2. Again, take notice of the correct interval. Filling out the interval leads to this expression. Now, the surface area 1/3 a to the power 3 over 2, should be the same as the surface area for area 2, which is 8/3 minus 1/3 a to the power 3 over 2. So we put them together in one equation and we just work out for a, which leads to this. A equals the cube root of 16. And this is the answer to the question. So in order to solve this question, all we needed to do was devise a plan on how to calculate both gray areas. And from that point onwards, we were just filling out the formula and the numbers. Now this question in this final exam consisted of 2 parts, and here's the second part. Let's carefully read the problem first. Given is the point A with coordinates 2, 0. For each point P on the graph of f, the midpoint of the line segment AP can be determined. We call that midpoint M. Furthermore, the function h is given by h of x equals the square root of half x minus half. In figure 2, the graphs of f and h are plotted. The line segment AP with midpoint M is also drawn for a point P. It holds that for every point P on the graph of f, the point M lies on the graph of h. Exercise: provide proof for this statement. So now we need to strategize. How are we going to attack this problem? How can you provide proof that a certain point is on a graph? Well, if you have the formula right here, if you have a certain x, and you fill it out here, and then you get the corresponding y coordinate. If we know the coordinates of point M, then we have an x and an y coordinate of M. So if you put in the x coordinate of M right here, then after calculating this part, the y coordinate should come out. Let's look at this in a bit more detail. First, let me get this away. Then let's start by define or determine the coordinates of point P, because we know the coordinates of M, the thing that we're really after, depends on the location of point P. Okay, so point P is on the graph of f, and we know that the function of f, we know from the previous exercise that f of x equals the square root of x. If the x coordinate of point P is called P, the coordinates of P are P, square root of P. Now with this we might be able to determine the coordinates of point M. Remember that point M is exactly in between point A and point P. Now we know the coordinates of point A, 2, 0, and we know the coordinates of point P, P, square root of P. So then M is the middle point of this line segment, in other words, exactly halfway between A and P. Therefore, the x-coordinate of M is exactly in the middle of point A, where x is 2, and P. So then the middle point between point A and point P in the x direction is half, and then P plus 2. And simplifying this is half P plus 1. Similarly for the y-coordinate, which is in the middle of point A, where the y is 0, and square root of P, which is the y-coordinate of point P. There we go. Now we need to prove that point M is on h of x. Point M has coordinates. X is half p plus 1 and y is half square root of p. So if we fill out half p plus 1 in the formula here, then filling out half p plus 1 for the x also here should lead to half the square root of p. So let's see if that happens. This is exactly what we have done here. You can see this is the same formula as here above, but then x substituted by half p plus 1. Okay. And then we're simply going to work this further out. And indeed, it turns out that the answer is half square root of p. So now we have proven that this point is indeed on the graph of h. That's it for today. Thanks for watching. Please leave a like and subscribe, and I'll see you in the next one.